This is our next type of indicial equation. We see this 2 here. We're going to use our thorough knowledge of powers to see that that is actually the same as 3x squared. And I guess I'm going to highlight it by putting these brackets in there. When I'm looking at that, I'm seeing that, which is just a quadratic equation. So if that bracket was an A, then I'm just going to do my whole brackets there. I'm going to go A minus, what's it going to be, minus 3, and A plus 2 equals 0. So I encourage you to do this, actually write the A when you first start out, but eventually you're just going to go, it's going to be 3 to the x minus 3 and 3 to the x plus 2 equals 0, and you don't need to then show that working. But for this, to start with, put those A's in there. And when you get here, you're going to apply your null factor law to get 3 to the x will equal 3, or 3 to the x will equal minus 2. I can't think of an x here to get a negative number, so that is an undefined answer. There's no such power of 3 that will give me a negative as an answer. And here, straight as indicial equations, I'm just going to go therefore, I can put a 1 there, x equals 1. So x equals 1 is our only answer. Okay, let's go on to the next jump, if you like. I think this is the question in one of the worksheets. It's a nice one. Whew, loving the look of that. Okay, we can see that we've got some sort of power of 5 happening. So this one's a little bit out of the ordinary, so we want to get rid of it, and we want to see that as 5 squared to the x, which is going to be 5 to the 2x. So that's going to be 5 to the 2x. See this 2x, and I've got this 2x here. So if I can get rid of that plus 1, that would be nice. So how about I go 5 times 5 to the 2x, because multiplying like bases, I would add the exponent, so that's my 2x plus 1. I just don't need to show that there. So now at least I've got my common base of 5 and my common power there. Similarly, this plus is a real problem because I can't get these exponents together because that's a plus. But what I can do is, just like I did over here, I'm going to get that 1 down the front. So that becomes 5 times 5 to the x. And this is going to be plus 5 squared times 5 to the x. Okay. Nice. Okay. We can't deal with these pluses, but you can see here on the left I've got 2 terms. This is a term and that's a term, and what's in common, I've got this 5 to the 2x. So I can factor it out. And what's left is I've got that 5 there, and that's 1 times, so that's 5 plus 1. Similarly, I'm going to factorise this 5 to the x out. So I've got 5 plus 5 squared outside of 5 to the x. Let's just neaten that up. Is 30 times 5 to the x. Let's get the 6 across here. Now I can go one of two ways here. I'm going to get this 5 to the x underneath. So I'm going to divide. So when I divide like bases, I subtract the powers. What's 2x minus x is just x, which is 5 to the 1, and therefore I can say x equals 1. The other thing I could have done here is gone, well, no, let's just leave it like that. That's just nice and easy. There's lots of different ways that you could have done that, but that's the concept that I want you to have a bit of a think about.